And so for number 5, our denominators are x plus 5 and x. And as with the last problem, there's nothing I can factor out of either one of those. So our two factors that we need to multiply together to get our least common factor are going to be x plus 5 and x. We'll just multiply them together. So we would have x times x plus 5. And that simplifies to be x squared plus 5x. I like using the one that is factored because I can see all the parts. If I use the x squared plus 5x, it's difficult for me to see all the parts. And so I'm going to go ahead and use the one that I highlighted yellow, x times x plus 5. And so what we would have is x plus 9 over x plus 5 times something will give us a denominator of x times x plus 5. And as you can see, we've already got the x plus 5. So the piece that we are missing is the x. So we're going to multiply by x in the denominator and by x in the numerator. That's going to make x times x plus 9. Now the other fraction, we have x minus 3 over x times something gives us x times x plus 5. And as with the other one, we can see we have an x, so we are missing x plus 5. So I need to multiply by x plus 5. That will give me x minus 3 times x plus 5. And one thing to notice in this problem, give me just one moment, I'm going to check something. Okay. And so the way that I'm going to handle this at this point is look at these and see if there's anything that I could factor out. And it looks like, or not factor out, I'm sorry, that I could divide out. The x plus 5s are going to be able to divide out. And at this point, there's a lot of different ways that you could handle this problem. I did this problem earlier, and I went ahead and multiplied everything through in the numerator and multiplied everything through in the denominator. I actually think that might be the easiest way to do business right now. And so I'm going to rewrite this fraction, or this set here, remembering that this is subtraction, which is kind of a pain. I got that minus sign in the middle up there, so we have x plus 9 over x plus 5. Or wait, what am I doing? I'm using the original. I don't want to use the original fractions. I need the new ones. So we've got x times x plus 9 over x times x plus 5 minus x minus 3 times x plus 5 over x times x plus 5. Now, because this looks difficult for me to deal with, I'm just going to multiply everything out so that I get things simplified. So I'm going to have x squared plus 9x on the left over x squared plus 5x. And then on the right, I need to remember to distribute that minus sign after I get everything multiplied out. I'll do this work over here on the side. X minus 3 times x plus 5 is going to be x squared minus 3x plus 5x minus 15, which simplifies to be x squared plus 2x minus 15. This problem is a bit of a beast too. So x squared plus 2x minus 15 over x squared plus 5x. And so now we just need to deal with that negative sign. I almost said combine like terms, but that negative sign needs to get distributed to all the pieces. So I need to rewrite this darn thing again. Holy moly. X squared plus 9x over x squared plus 5x plus a negative x squared minus 2x plus 15. over x squared plus 5x. And so now when I go to combine like terms, I have an x squared minus x squared, that's going to make nothing. I have 9x minus 2x is going to make 7x. And all that I have in terms of regular numbers is the 15. So I've got 7x plus 15 over x squared plus 5x is my final answer. The other way to do this is to say or, and you could factor the denominator if you wanted to. We can take an x out, and that would leave x plus 5. Again, either one of those are perfectly acceptable for Schlegel. That one's kind of a beast. Sayonara, problem number 5.